Okay, ladies and gentlemen, this is actually kind of a famous problem. It is, there's a mathematician named Carl Gauss who who is considered to be one of, if not the best mathematician ever in the history of mathematicians. So this guy, Carl Gauss. Even better than the guy in numbers. Now, the legend says that he was kind of a smart aleck in elementary school, and his teacher, to occupy his time, because you would think that this would take a long time, because they didn't have calculators. We're talking 1700s here. I think 1700s, maybe 1800s. But said add up all the integers from 1 to 100, and Carl Gauss came up about 30 seconds later with the answer. And this is what he figured out. He said, all right, well, what's 1 plus 100? 101. What's 2 plus 99? 101. What's 3 plus 98? 101. So he saw this pattern where if you take 1 plus 100, you get 101. You take 2 plus 99, you get 101. 3 plus 98, you get 101. Well, how many of these 101s are you going to get? How many? 50. Yeah, you're going to get 50 of these. So once he saw that this pattern was going, you'd make the first one and the last one. So you have 100 numbers, you're going to make 50 pairs. And so he just did 50 times 101, 5,050.
Okay, but how do you figure that out?
He did. His classmates weren't able to, but he was. And that's kind of one of the neat things, that being able to add up these series can have you do is you add up a bunch of numbers really, really, really fast. Now, yesterday, I know I showed you the formulas, but the formula here is S sub n is equal to n divided by 2 of the first term plus the last term. Now, if you take the first term, here's a sub 1, here's a sub 100. You got your first and your last terms. A is just one of these terms. This is A1, A2, A3, A4, A5. So it represents one of the numbers in the sequence of the series. Now, S sub n, this S sub n is the sum of n terms. If A sub n is a term, this says add them all up. Well, this is the formula for what Carl Gauss was able to do. If we were dealing with this, a sub 1 is 1, this is 100, and then all we have to take is 100 divided by 2, and that's the sum of the first 100 terms in this. And that's your 50 times 101. Pretty much, yeah.
Like the SN equals n over 2. Where did you get the 2 from?
The n over 2 would be the pairs that you make. There's 100 numbers in the sequence, but there's going to be 100 divided by 2, 50 pairs that equal that 101. 1 and 100, 2 and 99, 3 and 98, and eventually it'd be 50 plus 51. Now, want to show you a couple other things first. We're going to do a lot of these. If you see this, where it says I equals 1 to n, this is the same thing. This is called a summation, and it's just going to tell you to add whatever you got over here. And there's some rules that we have for this, but there's also some different things that we have. Now, for arithmetic sequences, there are two formulas you can use, or actually these are for series. Series are when you add the terms. A sequence is when you just have the list of numbers, the list of terms. A series is when you add them up. So S sub n, there's two formulas. The second one, it depends on what you know. The second one would be n over 2. And then there's a big thing here. 2a sub 1. I don't know why I dotted the 1, but it's okay. Plus n minus 1 times d. That's if this one is if you know the first and last terms. This one is if you know the first term only and the common difference. So we have a lot of the formulas based off of what you know. Say that again. This one? That's this one right here. Same thing. That's if you know the first and the last terms. All right. Now, if we take a look at this, evaluate the sequence. This is one where we know the first term, a sub 1, and the last term. 1, 2, 3, 4, 5, 6. So that's a sub 6. So I also know n is equal to 6. So I know a sub 1 is equal to 13, a sub n is equal to 23, and n is equal to 6. Now, at this point, we can figure out the sum n over 2 times a1 plus a6. Now, what's n? 6. So we get 6 over 2 times the first term, which is this guy right here, 13 plus the last term, which is 23. So now we're going to get 3 times 36. That's 18, carry the 1, that's 108.
That was easy.
Yeah, it's not bad. That's the same thing. 6 over 2, yeah. You're going to divide. Now, if you think about what that 3 represents, it represents, if I took this number right here, 13 and 23, add those together, what do you get? 36. Take 15 and 21, what do you get? 36. 17 and 19? 36. And there's 3 of them. And so, if you apply what Carl Gauss did to any sequence, if it's arithmetic. Not if it's geometric. If it's geometric, we have a whole different list of things that we have to do with that. But if it's an arithmetic sequence or series, then we can deal with those numbers at that point. Now, what would, for this guy right here, now how many terms are there? 7. So I go 7 over 2. And I need the first term, which is what? 6 plus 36. So this is going to be 7 over 2 times 42. That would, 2 divides into 42, you get a 21 times 7, that would be 147. Well, it would have been 2.5 times 20 or times 42. That's what it would have ended up being. But since I had it in a fraction and I know 2 can divide into 42, I could change that to a 21 and 20. So all I had to do is 21 times 7, and that's 7.
Oh, so when it's like it doesn't divide out to a 7.
Yeah, then you could divide, you could factor a little bit and get your answer. Now, for right now, I want to introduce to you 2 formulas. And they're up on the wall over there. Now, if C is just a constant number of some kind, if I'm going to take a summation from 1 to n, if it was like from 1 to 5, like this, if it said I'm going to take I equals 1 to 5 of x, this means x plus x plus x plus x plus x, which is equal to 5x. So the idea that if you just have a constant here, you just have to multiply whatever the n is times what the constant is. So if I took, for example, I equals 1 to 10 of 7, I just have to take the 7 and multiply it by the 10, which would be 70. Because this means 7 plus 7 plus 7 plus 7 plus 7 plus 7, 2, 3, 4, 5, 6.
What is that? I know. What is that sign called?
It's a summation. It's called a summation. It's the Greek letter sigma. Now, the other rule is this. If you have the summation I equals 1 to n of I, like a variable, it's going to be equal to n times n plus 1 divided by 2. C is a constant. Constant times the number of terms. Now, if this is a variable, where we would plug in the number, all we'd have to do is take the number of terms times the number of terms plus 1 divided by 2. So we could get these summations instead of having to add c. Like if n was 35, I wouldn't have to add 35 c's together or 35 sevens. I could just go 35 times 7. Or if I'm going from 1 to 100, it'd be 100 times 101 over 2. Now, one thing that you can do with the summation sign is that we can break this up. So we can do this. We can change this into the summation I equals 1 to 35 of 5k minus summation of I equals 1 to 35 of 2. So basically what we're going to end up doing is kind of expanding the different summations. Now, we can rewrite this as 5 times, we could take the 5 and move it out in front, 5 times the summation of I equals 1 to 35 of k. All right. Here are some other properties. If I have the summation of f plus g, this is equal to the summation of f plus the summation of g. So I can split them up, which will make our lives a lot easier. That's just what I did here, is I took the summation of the first term minus the summation here. Now another rule says if I have the summation of a constant times, for lack of a better thing, an x, I can rewrite this as c times the summation of x. So those are some properties with summations, because then we can use these formulas over here. Not that you're going to be able to use. I'm going to expect you to be able to do this by hand, yes. You want to zoom in on what? So now, all right, now we apply the formulas that we have, and they're just formulas. So it's going to be 5 times. Now, since it's the summation of the variable that we're just dealing with, it says I can use the n times n plus 1 over 2. So I could take the 35 times 35 plus 1 over 2 minus, now since this is just a number, all I have to do is take the number and multiply it by 35. So it's 2 times 35. Yeah, the k is just an x. That's all it ends up being. K is an x. Or m, because this one says this, k equals 1. K or x or m or I or j or k, or they just don't use n down there because n is usually the top number.
So wait, can you just
K is just a variable. We use this. When these two, when I here and I here agree, we can use this formula, where I just use the top number. In the first one is 35 plus 36 over 2. All right, so at this point, ladies and gentlemen, instead of belly aching about how you can't do this, you guys should be paying attention. All right, now we got an answer for this guy of 3,080 by just taking this and plugging it into the calculator. So this guy was 3,080.
Mom's up.
Wait, why didn't you just substitute the 5 into the summation first? Or did you?
I took the 5 out
Right, so after doing. Well, I'm kind of.
because I changed it into 2 summations.
Right, so the first one you have.
But you can't distribute that 5 to both summations.
Well, I'm saying like the first one you have K 35, so you put it, should you just put the 35? Where did the K go? That's my question.
The K stayed. The K went here, then it became the summation of, and this is actually K, of the summation of K, which allowed us to use this formula. So once I was able to use this formula, that's what you want to do. Is the whole idea behind this is you either want to get the summation of a number or the summation of a variable by itself. And so that's why we reuse this, so we can use these 2 formulas.
So then you took the K and put it in as for the N.
And well, once I got to this point and I saw it was a summation as K goes to 1 to 35 of just K, that's this formula right here. Because this is from I from 1 to N of just I by itself. So when I got just K by itself, I can use this formula and be done with it.
So what is N? 35?
Yeah, N is 35. N is always that top number.
Oh, and then plus 1.
Yeah, 35. Yeah, 35 times 35 plus 1 over 2. And then you just end up putting that in your calculator.
Where'd that other 35?
Yeah, where'd that come from?
The formula. N times...
Okay, gotcha.
Alright, now, let's just go through and rewrite this. Now, there's 2 terms. So I'm going to have 2 summations. Now, I look at the last one. This is just going to be the summation of I equals 1 to 35 of 13. Now, how can I rewrite the summation of 3i?
You take the 3 out and put it.
Yes. So you break this up, it becomes the summation of 3i minus the summation of 13. And then it becomes 3 times the summation, whoops, of I minus the summation of 13. And then you just apply your formulas after that.
And then you put it, so then it'll be 35 parentheses 35 plus 1 over 2.
Yeah, we use the n times n plus 1 divided by 2, but we have to multiply it by 3 because we had the 3 out in front.
Right.
And then minus, just take the number 13 times 35 because you're basically adding 35 13 times.
Is equal to 13 times. No, minus 13 times 35. So then, is that it? Do you
Then you plug it in the calculator, figure out what's up. Now, this guy right here, how am I going to break up 7m?
you take it out?
Seven with the like whatever it's called, and the I under.
And then a 10 on top. Minus, or M minus the summation and the I, or M minus 1, 10 on top, and then 2. And then you plug in that formula
That's it?
That's it.